One question mathematicians always seem to end up asking when they're thinking about a new kind of object is, how can I tell when two of these things are the same? In geometry, this idea of being the same is what's called congruence. We've already seen this with angles and segments, where we define two angles as being the same or congruent if they have the same angle measure, and two segments as the same if they have the same length. We can do something similar when we're looking at two triangles. We're going to say that two triangles are congruent if and only if their corresponding sides are congruent and their corresponding angles are congruent. Now, in this context, we get to figure out what the correspondence is. So, to see what I'm talking about, take a look at these two triangles. Notice that angles A and D are congruent, and that angles C and E are congruent, and finally, that angles B and F are congruent. Right, so now this is setting up the correspondence for me. A corresponds to D, C corresponds to E, and B corresponds to F. But it's not enough just to check the angles. Right? The definition says the corresponding angles and their corresponding sides are congruent. So once we set this correspondence up with the angles, I'm kind of stuck with the sides. The sides opposite the 50-degree angles have to match, and they do. The sides opposite the 60-degree angles have to match, and they do. And finally, the sides opposite the 70-degree angles have to match, and they do. Right, so there's my correspondence. Right, I kind of made it up as I was going along based on what I'm seeing in the diagram. Right, and because I have this relationship between the sides and the angles, I can say that these two triangles are congruent. Now you got to be careful about how you write this. I'm going to use the same congruence symbol that we use when we're talking about angles and segments. But when we write the triangles, you got to be careful because I have to write the letters of the triangle in such a way that you can infer the correspondence from it. So the way we write a triangle, I'm going to use a little triangle symbol, and then I'll just put the angles here: D, E, and F. Now, when I do the other one, I have to do them so that it shows the correspondence. The angle that corresponds to D in the first triangle is the 70-degree angle, so that one has to go first. The angle that corresponds to E is angle C, so that one comes second, and that leaves angle B to go last. Right? So that's how I would write that these two triangles are congruent. So that was a lot of work, right? We had to show first we had to kind of come up with the correspondence, and then we had to show 6 different congruences to come to the conclusion that we were looking for. Well, it turns out you don't have to go to all that effort every time, right? There are several shortcuts that you can use where you actually have to show a subset of those 6 things, right? And I've got 4 of them listed out here. And the names tell you what you have to show. So the SSS theorem, for example, is saying that all you have to do is show that all 3 sides are congruent, that 3 pairs of sides are congruent. And that's enough. You actually don't have to show the angles at all. If you can show that 3 pairs of corresponding sides match up, that's going to force the angles to be congruent as well, and you've got what you were looking to show. Now, these other 3, the order of the letters is important, right? For example, with the SAS, that's side angle side, what that's saying is that if you can show that a side, another side, and the angle in between them are congruent to a corresponding side angle and side in another triangle, then you're done. That's enough for the triangles to be congruent. The angle side angle theorem is saying an angle, and the side in between them. You can show that 2 corresponding angles are congruent and the side in between them is congruent. And again, that's enough. Right? Based on that alone, you can say the triangles are congruent. And finally, the angle side. It's an angle, and a side that they don't have in common. So it can't be this one here. It has to be one of the other two, right? And again, that would be enough. So in the next lecture, we're gonna look at a couple specific examples of pairs of triangles, and we're gonna see how we can use those theorems we just talked about to show that the triangles in the diagrams are congruent.